I am Sagarika from IT Department, Kannur University campus. My topic is ID3 decision tree and its applications. What is ID3? Iterative dichotomized tree. It states ID3 is a method to automatically generate decision tree from data. അതായത് ഡാറ്റയിൽ നിന്ന് ഡിസിഷൻ ട്രീകൾ സ്വയമേ സൃഷ്ടിക്കാൻ ഉപയോഗിക്കുന്ന ഒരു രീതിയാണ് ID3. It was developed by J.R. Quinlan in 1986 as one of the first algorithm for decision tree construction in machine learning. ID3 algorithm overview. Entropy. Entropy measure the impurity or randomness in a dataset. അതായത് ഡാറ്റയിലെ ഇമ്പ്യൂരിറ്റി അളക്കാൻ വേണ്ടിയിട്ടാണ് എൻട്രോപ്പി യൂസ് ആക്കുന്നത്. It is calculated using the formula h of s equal to minus sum of I equal to 1 to n pi dot log 2 of pi, where h of s entropy of dataset S, n number of classes or categories in the dataset, pi proportion or probability of example belonging to class I, log 2 of pi measure the information gain when an example belongs to class I.
Algorithm overview രണ്ടാമത്തെ information gain. Reduction in entropy after splitting data on an attribute. Gain s, a equal to h of s minus sum of number of example in subset SV divided by number of example in the dataset into h of SV. Here S means the entire dataset, A the attribute being evaluated for splitting the dataset, SV a subset of SS created by splitting on a specific attribute value V, H of S means entropy of the parent dataset, H of SV means entropy of a specific subset. ID3 algorithm is used to build a decision tree for classification tasks. Here is step-by-step explanation of how it works. First one, start with the root node containing all data. That means the algorithm begins with all the training data grouped into a single node called the root node. The root node represents the entire dataset. Second, calculate the information gain for all attribute. For every attribute in the dataset, the algorithms calculate the information gain. Information gain measure how well an attribute split the data into distinct classes. It based on entropy, which measure the randomness or impurity in the data. Third, split the data on the attribute with the highest gain. The attribute with the highest information gain is selected for splitting the data at the current node. The dataset is divided into subset based on the value of the chosen attribute. Each subset from a branch of the tree. Fourth, repeat recursively for each branch until termination conditions are met. The algorithm continues splitting the data for each branch by calculating the information gain for the remaining attribute in the branch. This process continues until one of the following termination condition is met. Key features of the ID3 algorithm. Split data into subset. Purpose, the algorithm divides the dataset into smaller, more manageable subset at each step. The splitting makes the classification process efficient by narrowing down the possibilities as the tree groups. 2. Choose the best attribute for splitting. To determine how to split the data at each step, the ID3 algorithm defines the most important attribute by calculating its information gain. Attributes with the highest information gain are considered the best for dividing the data into clear, distinct groups. Number 3. Stop when the job is done. The process continues until the data is perfectly classified or it's impossible to divide further. They ensure the algorithm doesn't stop too early or keep running when it is unnecessary. I use ID3. Easy to visualize and understand. Easy to visualize and understand ചെയ്യാനും വേണ്ടി പറ്റും. പിന്നെ can handle both large and small dataset. വലുതും ചെറുതുമായ ഡാറ്റാസെറ്റിനെ കൈകാര്യം ചെയ്യാൻ വേണ്ടി പറ്റും. Automatically select important features in the data. ഡാറ്റയിലെ പ്രധാന സവിശേഷതയെ സ്വന്തമായിട്ട് തിരഞ്ഞെടുക്കാൻ വേണ്ടി പറ്റും. ക്വിക്ക് ടു കമ്പ്യൂട്ട് ഫോർ കാറ്റഗറിക്കൽ ഡാറ്റ. കാറ്റഗറിക്കൽ ഡാറ്റയ്ക്കായി വേഗത്തിൽ കണക്കുകൂട്ടാൻ വേണ്ടി പറ്റും. Limitations. Overfitting can create overly complex trees that doesn't generalize well to new data, noisy data, sensitive to inconsistencies in the dataset, categorical data only, continuous data, need to be converted into ranges or categories. ID3, healthcare, predict disease like diabetes based on patient data. Example, if age greater than 40 and family history equal to yes, predict risk level equal to high. Marketing, segment customer based on buying habits. Example, if purchased product A, recommended product B. Finance, determine loan approval, attribute, credit score, income, employment type. Decision, approve or reject the loan. Next application, education, adaptive learning system. Example, if test score less than 70, recommended additional exercises. Next, technology, spam detection. Example, if subject contain win, classify as spam. How ID3 stands out. Core strength, effectively splitting. Focuses on dividing data by selecting the most informative attribute first, using metric like information gain. Second, step-by-step reduction of uncertainty. Builds the decision tree progressively, simplifying the decision-making process at each step. Third, transparency. Offers a clear and understandable way to trace and explain decisions. Why it is important? Foundation for advanced algorithms serves as a basis for more sophisticated algorithms like C4.5 and CART. Educational use. Frequently taught and applied in introductory machine learning courses and projects due to its simplicity and conceptual clarity. And improvements. Challenges. Scalability, data preprocessing, overfitting. Scalability means the algorithm can become inefficient when handling very large datasets due to computational complexity. Data preprocessing require data to be categorical, meaning numeric data must be transformed into categorical ranges before processing. Overfitting often creates overly specific decision tree that perform well on training data but poorly generates to new unseen data. Improvements. Pruning. Reducing unnecessary branches in the decision tree can help mitigate overfitting and improve the model's ability to generalize. Second, integrate ID3 into ensemble method like random forest for better results. Comparison with other algorithms. C4.5, an improved version of ID3, handle numeric data natively and incorporate pruning to address overfitting, often considered more robust and versatile than ID3. CART, classification and regression tree, similar to ID3 but support both classification and regression tasks. Next, random forest, combine multiple task decision tree for higher accuracy and resilience to overfitting. Conclusion. Summary of ID3. An easy to understand algorithm for building decision tree, focusing on splitting data step by step based on the most informative attributes. Ideal for small datasets and clear categories. Applications. Widely used in healthcare, marketing, and finance. Forms the foundation for more advanced tree-based algorithms. Future directions. Combining ID3 with machine learning technique for better scalability and accuracy.